What you're seeing here is the double-slit experiment, one of the most mind-boggling demonstrations in physics. It reveals that tiny particles, like electrons, don't behave as expected, they act like both particles and waves. Here's how it works. When a beam of electrons passes through two narrow slits, you might expect each electron to just go straight through one of the slits, creating two distinct lines on a screen behind. But that's not what happens. Instead, as these electrons hit the screen, they form an interference pattern, a series of alternating bright and dark bands, similar to what we see with waves of light or water. This pattern suggests that each electron is somehow going through both slits at the same time, interfering with itself. It behaves like a wave, even though we know electrons are particles. This phenomenon, known as wave-particle duality, is one of the central mysteries of quantum mechanics. To make things even stranger, if we set up a detector to observe which slit each electron goes through, the interference pattern disappears. The electrons behave like regular particles, choosing one slit or the other, and we're left with two distinct lines on the screen. So, what's going on? By simply observing the electrons, we change their behavior. It's as if the electrons know they're being watched and switch from acting like waves to behaving like particles. This effect has puzzled scientists for decades, and it challenges our very understanding of reality and observation. The double-slit experiment shows that at the quantum level, particles don't act in predictable ways, they exist in a kind of probability cloud, only taking on specific locations when observed. This discovery has deep implications, not only for physics but for our entire understanding of the universe.